I'm really glad to be doing this presentation because it's addressing an issue that I care a lot about, and that's the role of sleep health in society and the role of technology. And as always, I have too many slides, so I apologize if I go through them a little bit quickly, but I've got my contact information here. Here's my website. Follow me on Twitter, send me a message. If you have any questions or any issues, feel free to reach out. I definitely don't want you to hesitate to do that. Before getting into the meat of it, a couple of quick disclosures I just need to make. I do have grants from a couple of different organizations, and I have done some consulting for a number of different organizations as well, but except for anything mentioned, it shouldn't be related to any of this at all. That out of the way, I want to start with sleep and circadian physiology. And when we think about sleep science, we're thinking about sort of these sleep-wake centers that are deep in the brain, or these molecular controls of biological rhythms and the genes that control the molecules that control the systems at the cellular and tissue level that play roles in why sleep is related to health. But I'm not really going to talk about this today because that's not what the focus is. This isn't a course on sleep physiology. This is about the bigger picture. Sleep is a universal biological need. That's what this is about. People ask me all the time, why do we sleep? Is it true that science doesn't yet know why it is that we sleep? The truth is, we do know why we sleep. We sleep because we have to. We sleep because sleeping is a fundamental part of our biology. We sleep for the same reason we breathe air, eat food, and drink water, because if we didn't, our bodies could not function. It's not optional. It's part of how we're built. That's why we sleep. But that's not the interesting answer. The interesting answer is all the different things that sleep does. In the meantime, though, we're in a society that has a very complicated relationship with sleep. We often see sleep as unproductive time. And there's nothing worse in our society than unproductive time, right? And so we're constantly incentivized for unhealthy influences on sleep. So I'm sure everybody can think back to times not too long ago, probably, where they've had some incentive for sleeping less, whether it's they had to work on something and stay up late, or had stuff that they needed to get done, and somehow staying awake and not getting healthy sleep, or waking up too early or whatever, was somehow encouraged societally. I mean, we reward people for showing up early and staying late as if that means they're harder workers, even though they're not. And this has led to these discussions about sleep. I love finding sleep images online. Here's one I found recently. And I think it speaks to sleep health in two ways. One, it does illustrate the societal attitude towards sleep, about how we sacrifice sleep often. And so sleep problems are very common in society. But at the same time, I really like that this is starting a conversation. That the other side of this is that we're starting to, wake up, so to speak, to the idea that sleep is actually important for health and functioning. And so I like these images that paint this picture. So these ideas that sleep is not important, that sleep is unproductive, all these sort of things, not only is that incorrect, because it is not correct, but these are harmful ideas as well. And so I'll get into a little bit why. In the meantime, I want to talk a little bit about our current state of sleep health. Here's some US-based data where you could look at where the hotspots are of insufficient sleep. You could see that lots of areas of the country have a lot of insufficient sleep. These are people who say they don't get enough sleep. There's also maps for poor sleep quality and daytime fatigue. And I'm sure if you looked at other countries around the world, you see these geographic dispersions, which show that it's clustering, which means that there are environmental, social, and behavioral influences. It's not just purely biological. There are other things at play here. In the US population, about half the population is getting the 7 to 8 hours of recommended sleep. About a third is getting 6 hours or fewer. And this is a problem because it's the 6 hours or fewer that are associated with worse outcomes, especially the 4 hours or less. That's the extreme short sleepers. There are some long sleepers, about a little under 10% of the population getting 9 or more hours of sleep. That's a complicated group. Sometimes they are at high risk for adverse outcomes. Maybe it's because the longer sleep is sometimes tied to worse health. If you're somebody who's sleeping 10, 11 hours, I'd be curious as to why, if you don't have a medical condition. Some people may need more and be fine. So that's an interesting group. But the bigger group is the short sleepers, you can see, about a third of the population. And it's not just amount, it's also quality. So here's some US-based data of what proportion of the population reports difficulty falling asleep. About 1 in 5 reports it at least a night a week. And about 1 in 10, a little under 1 in 10 reports it at least half the time. Similar for difficulty resuming sleep by waking up in the middle of the night. Also, a lot of people are reporting early morning awakenings, where they're waking up early in the morning and have trouble getting back to sleep. And non-restorative sleep, about a third of the population is saying at least a night a week, they're just not feeling refreshed by sleep. So these are important outcomes. And this is each one of them. The combination, the likelihood that someone's going to have at least one of these is about a third of the population, at least. And you also have sleep apnea. I'm not going to talk about sleep apnea a lot, but it's a huge public health issue. This figure shows the amount of the population of men who are over 30 or over 50 and women over 30 and over 50 who likely have at least mild sleep apnea. And you can see the rates are shockingly high. It is tied to body mass index and obesity. That's what the numbers are here. And you could see that people who are obese have very high rates of sleep apnea, but even people who aren't obese, you're looking at having rates among men among 20% in people who aren't obese but may be overweight. And even women too, you have these high rates. So sleep apnea is another big population sleep health issue. So when you take sleep apnea, insomnia, insufficient sleep together, you have a lot of sleep problems in the US population. And this is important because sleep relates to longevity. The first study linking sleep and mortality was actually published back in 1964. That's how long we've known that not getting enough sleep or excessive sleep is associated with a shorter lifespan. Since that time, over 50 different longitudinal studies have shown that habitual short sleep and habitual long sleep also are associated with a shorter lifespan. And the further deviation from that normative range, the greater the risk. So here's some data from the largest study of all those dozens of studies that was done. This is the largest one that was ever done. It involved over 1 million people, followed over about 10 years, where they're looking at, on the y-axis is the hazard ratio. This is the increased likelihood of dying sooner based on how many hours of sleep you got. You could see the lowest risk was in the 7 hours, and it just goes up in both directions from there in this U-shaped relationship. That deviation sort of from the normative range is actually associated with a shorter lifespan. So you've got sleep that leads to mortality somehow. And so this is important. But what's in the middle here? What is it that sleep is related to? What's downstream of sleep that might be contributing to the shorter lifespan? And so this is what I and others have tried to dig into as much as we can. And really what you see is this whole constellation of different aspects of health, all related to sleep, all downstream from poor sleep. You have metabolic health, you have cardiovascular health, immunologic health, mental health, behavioral health, and cognitive health. All of these are related, which is why you see these are boxes within a bigger box. If I was going to draw all the arrows from all of these pointing to all the other ones and how they all cause each other, it would just be a big mess of arrows on the screen here. But really, all of these are interconnected. And sleep is upstream of all of them. It's not the only thing that's upstream of them, obviously, but it is upstream of all of them, and they all seem to be related to sleep health. And there's lots of data out there. I'm going to cut out a lot of it, just cut to a few examples. One example is drowsy driving, talking about sleep related to cognitive health. So here's a real world example of a cognitive task that sleep can be impacted by. So when you're driving, you have to remain vigilant, you have to pay attention, you have lots of decisions you need to make, even if most of the driving is kind of boring. And so we looked at some population level data, looking at who's falling asleep at the wheel. And not surprisingly, people who are getting 6 hours of sleep are about twice as likely to nod off at the wheel than people who are getting about 7-8 hours. And the people who are getting less than 5 hours were more than 3 times, almost 4 times as likely to be nodding off behind the wheel. So how much you were sleeping predicted whether you're nodding off. And you can see unadjusted and adjusted. Adjusted means we took out the contributions of things like age and sociodemographics and socioeconomics and things like that. But what was interesting about this data set was there was also, this was from the CDC, and they also had a question of how many nights have you not gotten enough rest or sleep? And so what we did is we looked at the people who only said 0. These are people who said 0 nights in the last month they didn't get enough sleep. These are totally well-rested people, right? Totally, totally well-rested. So I figured one of two things would happen. Either this would be a good indicator of the real-world short sleepers that are actually fine. There probably are some people getting 5-6 hours that are doing totally fine. And maybe if people say they're totally 100% well-rested, even if they're getting 5-6 hours, maybe they're fine. Or the alternative is what we see in the laboratory would bear out in the real world, because in the laboratory, when you sleep deprived people, they have no clue how impaired they are. They think they're doing okay. They think they're hanging in there, especially after a few days. They think they're not getting worse. But the truth is they are. They get worse and worse and worse over time. And so maybe the laboratory studies were actually correct. And in the real world, people have no clue how impaired they are. It was one of those two things. Turns out it's the second. People have no clue how impaired they are. People who say they are totally 100% well-rested, they're about 2.5 to 3 times as likely to nod off at the wheel if they're getting 6 hours or less of sleep. It's how much sleep you get that is important, not how well-rested you think you are. So this is a problem because we want to tell people, well, I'm getting 6 hours of sleep. Is it enough? Well, how do you feel? Do you feel well-rested? Well, it turns out people have no clue how well-rested they actually are. So this is a problem. Mental health is another important issue. The relationship between insomnia in particular and depression is one of the most well-established findings in all of sleep research, and maybe even all of medicine. This has been known for decades, that insomnia and depression are intimately entwined with each other. Poor sleep quality is associated with every single symptom of depression. So here's a study we published recently where we went through the 9 items of the PHQ-9 survey, which is all the different clinical symptoms of depression, whether it's anhedonia or decreased interest in things, depressed mood, sleep disturbances, tiredness, appetite symptoms, feelings of failure, trouble concentrating, psychomotor symptoms where you're either slowed or excess fidgety, and suicide ideation, showing that people, this is real world people, not insomnia patients, but the degree to which they have sleep difficulties, to which the degree to which they have daytime consequences of sleep difficulties, and the degree to which their perception of their sleep being not good quality, each one of those was independently related in some way to each of these aspects of depression. So it's not just depressed mood, it's all of these features of depression are separately related to sleep. Suicide ideation is something that we've been, and suicide risk is something we've been focused on in our lab over the past few years. So here's a study, it was actually just recently published, where we looked at young adults and we showed that each additional night where they said they didn't get enough sleep increases their likelihood of having thought about suicide. Even after we control for the contribution of depressed mood, you see each night of that they're not getting enough sleep increases their likelihood that they were going to be thinking about suicide recently. At the national level, what you see is this pattern where people who are awake during the night are more likely to be thinking about suicide, and people who are awake in the morning are slightly less likely. So here you can see in weekdays on the top and weekends on the bottom, this is using national level data where we looked at people who reported suicide ideation in the last, I think it was in the last 30 days, or maybe it was the last 2 weeks. If they reported experiencing some suicide ideation, and then we looked at their habitual sleep schedule. And if there are people who are habitually awake at night, they're more likely to be thinking about suicide. When you look at actual completed, actual deaths by suicide around the US, we were able to filter out the proportion of the population awake at each hour. And when we filter that out, suicides spike in the middle of the night. Here you can see, here's our data from men and women, where you see the spike in suicides occurring 2, 3 in the morning. That's when they're happening, when it's greater than you would expect by chance. So being awake in the middle of the night is not only associated with more thoughts of suicide, it's actually associated with more death by suicide. And we're trying to understand the connections here. It's probably a combination of the stress, emotional issues, but then also your brain's not thinking well in the middle of the night. You might be more likely to make bad choices. Other aspects of health. Sleep is related to many aspects of chronic disease. Here's some data. We looked at national level data from hundreds of thousands of Americans showing risk of obesity on the left, hypertension or high blood pressure in the middle, and diabetes on the right. And you could see that the very short sleepers, so the line on the bottom is the rates you'd see in 7 to 8 hour sleepers. Compared to those, you have elevated risk in the short sleepers and especially very short sleepers, and to some degree also some of the long sleepers. You have more obesity risk, hypertension risk, and diabetes risk. But you can see here that especially the very short sleepers, they're 35 to 58% more likely to be obese, depending on whether they're male or female. But even the short sleepers, the 5 to 6 hour sleepers, 30 to 35% more likely to be obese. But this is just an overlap. What causes the other is still kind of complicated. It's probably bidirectional. So we look at incidence studies to see if you take people who are not obese and you just track how much they're sleeping, does it predict who's going to become obese? Here's a meta-analysis that lists a whole bunch of different studies that were done. And what you can see here is that on average, you can see the number 1.55 on the bottom. That means that on average, people who are short sleepers are 55% more likely to become obese than people who are 7 to 8 hour sleepers. When you pool all the studies together, that's about the risk. Hypertension, you see about a 20% increased risk of developing high blood pressure, even if you didn't have it before, if you were a short sleeper. Looking at diabetes, it's about a 30% increased risk. When you pool all the studies together, what you see is the people who are habitual short sleepers getting 6 hours or less, depending on the study you're looking at, the short sleepers in general are about 30% more likely to develop diabetes over time if they didn't have diabetes before. So why? Because sleep is related to so many biological functions, these chronic diseases accumulate risks slowly. And by going a long time without getting enough sleep, for sleep to be able to contribute to health, it can lead to these problems. But it's complicated. The relationship, because these are accumulated problems, you might look at the relationship with age. Now, sleep does something really interesting and paradoxical with age. So on the left here, you see data on sleep efficiency. So sleep efficiency declines with age. So sleep efficiency, for those who don't know, this is the proportion of the time you're in bed that's spent awake. So people who spend more time in bed awake are up more during the night, for example. And as you get older, you can see sleep efficiency drops and goes down. People wake up more. Their sleep is more shallow as they get older. But there's this other finding, and we've seen it and others have replicated it too, that what also goes down with age is actually complaints about sleep. So this is data on how many nights a week of insufficient sleep you have compared to 80-year-olds. We also see this in sleep debt. We also see this in poor sleep quality and complaints about sleep. Actually, sleep may be shallower. There may be more awakenings. There might be more objective trouble with sleep, but sleep interfering with life actually seems to go down with age. Again, and even after adjusting for sex and socioeconomics and other things, it seems to be a consistent pattern. Actually, the 25 to 35 to 40-year-olds, those are the ones who are complaining the most about not getting enough sleep. Where they might be getting objectively better sleep than they will in their 60s and 70s, but the people in their 60s and 70s might be more resilient to handle some of it. And what you see here is that relationship bears out in health. So here's a 3D image where we plotted age, how much people are sleeping, and what their body mass was, controlling for a whole wide range of things that could also be contributing to health. And what you can see is a complicated distribution that changes with age. So when we slice this out, this is what we see. Younger adults, you see this linear relationship where the more younger people need more sleep. So the longer sleep was associated with the lower body mass index. And then as people were getting older, the benefits of extra sleep seem to be going away. And you start getting this U-shaped relationship once you start entering about middle age, where longer sleepers were a little more likely to be obese and had a higher body mass than the black line, which is the 7 to 8 hour sleepers. So they were looking more like the short sleepers. This might be an indicator that if you're in your 40s and you're getting 10, 11 hours of sleep, maybe you have other health conditions that weren't otherwise controlled for, or something else is going on, because most people at that age who are employed aren't able to sleep 10, 11 hours. but also the very short sleepers too have higher BMI. But then once you get to retirement age, all these groups start collapsing on each other, and the amount of sleep isn't predicting your weight anymore. But that makes sense. If you're overweight as a 70-year-old, how you slept for the last 2 weeks probably isn't what the cause is. It's probably a lifetime of accumulated risk factors. But we see this in hypertension as well. So here's some data that we looked at over 700,000 people and showed that you could see the hours of sleep and the strength or the level that there was a significant relationship with hypertension risk. You can see that above age 70, unless you're in an extreme short sleep group, there's not the same risk with high blood pressure as you see in other ages. So you can see this is the U-shaped relationship, but it varies by age with hypertension. One of the pathways might be what you eat. So this is a study run out of Colorado where what they showed was when they restricted people to 5 hours in bed versus 9 hours, they ate slightly less at breakfast, no difference at lunch, no difference at dinner, no difference snacking during the day, but you could see a huge difference in post-dinner snacking in the same people when they were sleep deprived. So when you sleep deprived people, they start getting hungry at night and they start eating more. This might explain why. So here's some data from Marie-Pierre Saint-Onge's lab in Colombia showing that people who sleep less actually burn more energy during the day, slightly. But it looks like what's happening is they're actually burning more energy at night because they're awake when they're supposed to be asleep, and being awake spends more energy than sleep. Sleep saves energy. So what might be happening is your body's burning more energy at night because you're awake when it wants to be asleep. So then maybe you start craving energy to make up for that loss, and you start overcompensating. Here's my favorite study that was done in this area. This was at Penn. Andrea Spaeth and ran this study with David Dinges and Nicole, where they had sleep-deprived people for 5 nights of 4 hours to simulate a sleep-deprived work week. And then they were able to recover. What you can see here is that the control group didn't have any weight change over the week. But the people who were sleep deprived, they gained about 1 kilogram or about 2 pounds in just 1 week. And you could see it was different, like who you are and where you came from actually predicted how much weight you were going to gain. So if you were white, actually, this is in Philadelphia, if you were white, you gained less weight on average than if you were black. If you were a woman, you gained less weight on average than if you were a man in this study. So why? Still not sure. But it's definitely an interesting pattern, and it'll be interesting to find out what's going on here. But part of what might be happening is when they were eating. So you can see similarly in the morning, slightly less consumption of food. During the day, no difference. You can see at night, there's only 1 bar of caloric intake, and that's because the other group was asleep. People who were awake, when they stayed up about the time their body wanted to go to sleep, they started eating, and they ate about an extra 500 or more calories per day at night, and that was probably what led to the weight gain. A little bit about inflammation. So short sleep is associated with a pro-inflammatory state. So it leads to elevated inflammation throughout your body, both in the lab and in the general population. Here's some data. We looked at national level data showing this U-shaped relationship between how much you sleep and circulating levels of C-reactive protein, which is an inflammatory marker. On the right, you can see what the relationship looks like after we factored out things like demographics and obesity and insomnia and sleep apnea and other things that could be contributing to inflammation related to sleep. You see this U-shaped relationship, especially at the extremes. And this impacts getting sick and your immune system. So Eric Prather at UCSF has done awesome work in this area. On the left, you could see who catches colds. And by tracking people's sleep, you could predict who is more likely to catch a cold. The people who slept less were more likely to get colds than the people who slept more. Getting at least 7 hours of sleep on using a acculturation wearable device predicted lower likelihood of catching colds. On the right-hand side was another study they did where they looked at catching head or chest colds and also other viruses and other infections, whether it was flu, pneumonia, and ear infection. And in the middle, you see the people who are getting especially 5 hours or less of sleep, or even 9 or more hours having decreased likelihood of getting sick. The very short sleepers were much more likely to get sick, catching colds or other acquired infections. Then when they looked at sleep quality, so how likely was it that people who weren't sleeping well, even if they were may or may not have been sleeping enough, but how well you sleep also impacts it. So it's not just how much you sleep, it's also how well you sleep that impacts your ability to stay healthy. This is also related to vaccine effectiveness. So there's studies that show that like flu shots are more effective if you're well rested, for example. Smoking, so here's a paper we recently published looking at smoking. So nicotine is a stimulant, though a lot of people smoke to relax. And one of the things we showed here was smoking is associated with being a short sleeper. People who smoke are more likely to not be getting enough sleep, even after adjusting for all the other things that could be related, like health issues and things like that. And it seems especially the people who are smoking at night. So one of the things that we found was that the people who smoked after 11 p.m. were more than twice as likely to have sleep problems. So we talked about health issues and behavioral health issues, and we talked about mental health. So sleep loss is related to both poor physical and mental health in the brain and in the body. And it's possible that these effects overlap. It's no coincidence that it's affecting both of them. And I want to remind people that a lot of physical health conditions like diabetes and obesity and immune dysfunction and metabolic dysfunction, they're all made worse by things like increased stress and greater difficulty making healthy decisions, especially in the middle of the night. And so the effects on the brain and the effects on the body are likely intertwined with each other. So by impacting the brain, you're also impacting things like obesity and metabolism and inflammation. And that's because we think about sleep as this biological thing that happens, but it exists in a social context. So Simon Williams is a sociologist in the UK, and this is a quote from his book, but I love this quote: "When we sleep, where we sleep, and with whom we sleep are all important markers or indicators of social status, privilege, and prevailing power relations." And that's true. Sleep isn't just a biological phenomenon, it's how we embody the world we live in. And that's why it touches so many aspects of health. So here's the model that we've been going with in our lab and how we're conceptualizing sleep in context. So we have sleep here. Downstream, you have all these different domains of health that are all interconnected with each other. But what's here? What's upstream of sleep? If sleep is important, where does it arise from? And so we're taking what's called a social ecological approach. So we see sleep, the immediate drivers being at the individual level. These are your own individual level beliefs, your attitudes, your choices, your health, your psychology, your genetics. These are all the things that if you cease to exist, they would cease to exist. And if you think about where and how and when you slept last night, it was probably driven by your own choices and your own behaviors and your own health and your own life. But the individual is embedded. This isn't a separate circle. This is the individual is within the circle of the social level. These are things that exist outside of you: your family, your neighborhood, your job, your culture, your social networks. All of these things, if you cease to exist, they'd still be there, and you are part of them, and you're embedded within it. And all of these individual level sleep-related choices, beliefs, attitudes, and biology is all embedded from the social level. So one way to illustrate this is how many nights of sleep in the last week did your sleep schedule or pattern or experience have nothing to do with your job and when you had to get up for work, or what work you had to do at night, or family obligations, or what street you lived on and things you had to do? All of these things drive the individual level behavior. So ignoring the social level, I think, ignores a really important part of the story. And even still, there are things that the social level are embedded within that drive sleep, and that would be the societal level. These are things like globalization, or like 24/7 society, or racism, or technology, or climate change. These are, and public policy and laws. These are things that exist outside of all our social level networks that drive them. The fact that so many of us sleep with a mobile device that's connected to the internet, that we could talk on, message on, buy things on, read things on, watch videos on, within arm's distance from where we sleep every night, is not a coincidence based on individual level choices. And it's not even a coincidence that everyone's work changed and family life changed that use these things. It's that society changed. And if we're really going to understand the role of sleep in health and technology and society, we have to understand sleep in these contexts. That sleep is sort of at this intersection point between the world we live in and that we inhabit and the world inside of us, our biology, our mental health, and our brain and our body. Some ways that the social environment impacts sleep is actually disparities in race, ethnicity. In the US, if you're a minority, in most cases, you are more likely to be not getting enough sleep. So here's some national level data from a few 100,000 people across the US, particularly Black and African-American adults in the US are significantly and robustly more likely to be short and very short sleepers, and in a lot of cases also long sleepers. But you see it in other racial ethnic groups as well. Especially this black-white difference in the US has been quite stable. So we looked at data going back to the 1970s, and look how parallel these lines are about the proportion of the population getting 7 to 8 hours of sleep. It looks pretty parallel to me, but then we looked at more recent data over the past 10 years. And what we're showing is that as a society, we're actually sleeping slightly less now than we were 10 years ago. We're losing about 3/4 of a minute of sleep per night per year. So we're losing a few minutes of sleep here and there, and it's accumulating. I mean, if you think about it, even 1 minute per night on average, that's another 6 hours of sleep per year that you're losing, 365 hours or minutes. But what's particularly interesting here is not only is society sleeping slightly less, but it depends on what group you're in. So what we showed was that the average white person in the US is losing about a half a minute of sleep per night, per year. If you're Black in the US, that's actually about double. And actually the other group that was significantly more than white, the other groups were no different from the white group statistically, but Mexican Americans in the US are losing more than double the amount of sleep per year than non-Hispanic white adults in the US. So these disparities may be getting worse. What could be driving it? Lots of different things. One of them could be discrimination. Discrimination itself seems to be a predictor of poor sleep after you even adjust for the contribution of depression and depressed mood. That people who experience discrimination are more likely to have sleep difficulties, they're more likely to have insomnia, they're more likely to be not getting enough sleep, even after adjusting for whatever role depression played in this. Acculturation is also an issue. So here's some data we gathered at the US-Mexico border. We measured acculturation. For people who don't know, acculturation is a way to quantify how much you identify with and ascribe to a certain cultural background. So we used a scale called the acculturation rating scale for Mexican Americans, which has separate scales for Mexican acculturation, Anglo acculturation, which is, you can sort of think of as how Mexicanized you were versus how Americanized you were. You could be high on both. You could be low on both. You could be higher on one than on the other. On average, people of Mexican descent living at the US-Mexico border have higher Mexican acculturation than Anglo or American acculturation. But when we looked at those levels of acculturation predicting sleep outcomes, what we found was degree of Mexican acculturation among people of Mexican descent living at the border actually was not correlated much with the sleep outcomes. This was a smaller sample, so as we get more people, it might emerge. But what was correlated was the Anglo acculturation. So the more Americanized you were, the higher your ISI score, which means your worse insomnia symptoms. The higher your PSQI score, which means worse daytime sleep quality. The less sleep you got. And the higher your MAP score, so the more sleep apnea risk you had. So the more Americanized you were, actually the worse sleep you had. And socioeconomics plays a role in this too. You have socioeconomic disadvantage and you have poor sleep health. And it's been relatively well studied now that people with lower socioeconomic status are more likely to have worse sleep health. But I would argue this is a bi-directional relationship. The poor sleep health actually contributes to worse outcomes in general that can keep people in relative disadvantage. So there's a few potential things in the middle here. One would be, and I think this is the biggest one, decreased autonomy. So money does not buy sleep, but it buys control, it buys choices. So people who are at socioeconomic disadvantage have a decreased ability to control their time use, the number of demands they have, their expenses, and their environment. And people with poor sleep health tend to also have less control, which can lead to more disadvantage. Financial stress, whether it's housing, food, employment, or health related, all associated with poor sleep. Psychological stress, whether it's family-related psychological stress, cultural stress, discrimination, hyperarousal, all these things are bidirectional. Depression, unhealthy substance use, whether it's stimulant overuse, over-caffeinating because you're trying to work 2 or 3 jobs, which then leads to poor sleep, for example. But also more smoking and excessive alcohol use to potentially cope with stress or deal with lack of sleep. Illness and debility are higher in people who are disadvantaged and people who have poor sleep health. And more injuries and accidents, where poor sleep health, we talked about drowsy driving, can lead to more accidents. And also people who are more disadvantaged are more likely to be put in more dangerous situations, for example. So these are all ways that this is a bidirectional relationship. So poor sleep health and socioeconomic issues are intimately linked with each other. Just a little bit on data. Housing-related financial stress, more likely to be a short sleeper. Food-related financial stress, food insecurity, strongly related to sleep problems and lack of sleep. So what should we do about it? Well, we've got guidelines. So the American Academy of Sleep Medicine and Sleep Research Society say you should try and get at least 7 hours. That seems to be what the data said. In the old, people used to say 8. Looks like 7 is the new 8. Looks like the data show that if you're experiencing about 7 hours of sleep on a typical night, and you're otherwise free of health issues, that's probably enough for optimal functioning. National Sleep Foundation also said 7 hours, but they sort of said more than 9 hours, you might start getting diminishing returns. Where the American Academy and Sleep Research Society statement didn't have the upper limit in terms of where the agreement was, where that upper limit was. American Thoracic Society, this is the main organization of chest physicians. They do a lot of pulmonary and lung work. So a lot of sleep apnea physicians are in this group. So they had a statement about 7 to 9 hours. American Heart Association also had this minimum 7 hours. So the guideline is 7 to 9 hours, at least 7 hours. Most people aren't getting more than 9 anyway. That seems to be what a healthy adult should be striving for. But guidelines aren't enough. If recommendations were interventions, nobody would smoke, right? Just telling people what to do is not enough. Life is complicated. So what else could we do? And so here's an example of a model that can be applied to sleep health. This is something called the health belief model. And anyone out there who's struggling with sleep or trying to develop sleep health programs, they should be thinking about this model because it's one of the better ones, and it's really succinctly addresses key ingredients you need to be able to make a behavior change. And anyone out there who's even watching this or listening to this who has had trouble getting healthy sleep, I wonder how many of these apply to you. So in order to make a healthy change, ingredient 1, you need to have perceived susceptibility. So people need to be on board with the idea that whatever it is they're doing is causing a problem. If they don't think it's causing a problem, they're not going to change. The next you need is perceived severity. And they need to not just believe that it's causing a problem, but that the problem is important enough that it's worth changing. So it's not just enough to convince people that lack of sleep isn't good for you. It's that for example, you have to believe that lack of sleep isn't good for you in reasons that you care about, in domains that you would be willing to change for. So you need to have that. It's a required ingredient. The next required ingredient is addressing potential barriers. This is probably the most important, I think, where it's, okay, I'm on board. I'm on board with what I'm doing isn't healthy, and I'm on board that it might be causing bad outcomes, and the barriers are all the buts. This is, but I can't because I have work, I have this, I have all these things. These are all the barriers. You have to address the barriers. Barriers are almost always addressable, but you need to address them. If you don't address the barriers, you're dead in the water, you're done. And you need potential benefits. So let's say you cleared out the barriers, but it's still a hassle. You still have to go to bed earlier, and going to bed earlier is no fun. So if you engaged in the behavior, So not only are you on board that not doing it leaves you susceptible and in ways that impact you that matter, and you've addressed the barriers, but are there benefits from doing anything? Would doing anything actually fix the problem? If you don't believe it will, you're not going to change behavior. So that leads to perceived threat. So you have to believe that it's worth doing something about, and outcome expectations, where doing something will give you a benefit and you can do it. You've removed the barriers. The two other ingredients you need are self-efficacy and cues to action. Self-efficacy is the belief that the perception and the idea that you actually can engage in the behavior. If it's not physically possible for you to do, you're not going to do it. Or at least you don't believe it's physically possible, you're not going to do it. If you're saying like, look, my body can't sleep for 7 hours. I wake up after 4 hours and I cannot get back to sleep because I have really bad insomnia. Well, you don't have self-efficacy for sleep. We have to figure out how to fix that. If you don't have that, it's not going to work. And then you also need cues to action. You need reminders. You need a structure and a scaffold to help support that behavior. Otherwise, it'll die on the vine. So those are the 6 ingredients you need according to the health belief model, which is an old model from the 1960s, but it works really well. You need to know what you need to believe all these things, and then you can get a healthy behavior. There are other models like that too, but I want to challenge people to think about this idea that behavior change is complicated, and it's not just telling people what to do. It's also, it's understanding where they're coming from, helping them wrap their head around the idea of what the actual threat is, removing the barrier, and helping to strengthen the benefits, and help people be able to actually do it. I think autonomy is a key thing here. This is a paper we recently published looking at control over sleep. So people who say they don't have control over when they go to bed or wake up, how much they sleep or how well they sleep, they have worse sleep. People who are out of control of their sleep don't have worse sleep quality, see the PSQI score. They have worse insomnia, so see the ISI score. They have more daytime sleepiness, so there's the ESS score, and they sleep less. So control over sleep, I think, is really important. And I think this is a neglected area where we're so focused on proving that getting more sleep is beneficial. We haven't focused as much as a field on how to actually make that work and give people that control. So I think that's important. So why do people make changes to their sleep on their own? So we assessed this in about 1,000 people. And what we found was the things that drive changes to sleep are beliefs that sleep is important. So if you've, and everything that's glowing here, this was statistically significant. So sleepy driving wasn't something that actually promoted healthy sleep behavior or change. Same thing with changes to blood pressure. Well, blood pressure did. So what else didn't? Sleepy driving was one. Changes to sex drive actually wasn't one that seemed to motivate a lot of behavior. What were the big ones you can see were moodiness, energy level, and tiredness. Those seem to be things that drove a greater likelihood of people making change about their sleep. But then we looked at these and like, well, a lot of these are related to each other. So if you think sleep is important for your energy, you probably also think it's important for your performance. Also, it's probably important for your health and your weight and your heart. What are things that are unique? What are things that what are the main unique pathways here that aren't all overlapping? And what we found was the two are moodiness and weight. So in my mind, that's mental health and metabolism. So so people who believe that sleep is related to their mental functioning, they're making changes to it. And same thing if they think it's related to their weight management, that's the driver that's separate from the mental functioning, is their weight. So maybe that's what we need to do to promote sleep health, is stop talking maybe about daytime sleepiness or drowsy driving, or even energy level or diabetes or memory. Maybe what we should be talking about is mental health and mental functioning, and also weight management. And if you're going to have a program, that's why it's got to have all these ingredients. You've got to assess to get a needs assessment to see what you even need to do, boost people's control, have a socialization component, because sleep is very social. And so if the people you're looking up to or interacting with are not engaging in healthy sleep, you might not either. They're up late and they're engaging with you to do the same. Readiness is important. People need to be ready to change. If you're not on board with making a change to your sleep, you're not going to be able to do it. Education is important to help promote that readiness, where people have to understand why sleep is important. And then you need facilitation. This, I think, is probably the most important piece, the one we know the least about, is how to remove these barriers. Because I think most people don't sacrifice their sleep because they hate sleep so much. It's because they feel like there are these other barriers that are in the way of sleep. And if we can address those, I think we can make a positive improvement. So what should we be doing? We must address this context. It's probably out of clinics, addressing situational constraints, beliefs, and attitudes. It probably occurs on multiple levels, individual level, a group level, or even a system level change like school start times. But it's not just recommendations. We have to actually get down in there. And there are some things that our group is working on, but they're not all published yet. But we're working on this, and other groups are trying to answer this. But I want to end a little bit talking about technologies for a few minutes. Commercial sleep tracking was introduced about 10 years ago with a huge uptake and a lot of innovation. I mean, sleep tracking technology has been around since the 70s in research, but since in the last 10 years, it's exploded with huge amounts of innovation. And I think we started with this trigger, went to this peak of inflated expectations, and then we dropped into this trough of disillusionment with sleep tracking, where people were feeling like, well, what am I actually getting out of this? Is this even accurate? Is this even helpful? But now I think we've approached the slope of enlightenment, where we're starting to realize what the benefits of these things are and how to best use this information. And hopefully we'll get to the point, the plateau of productivity, where we're actually using these devices optimally for what they're for. So we had some of these problems and lost momentum, but we've been more recently rethinking the value of sleep technology, and now there's quite a bit of renewed interest. So there's some problems with devices right now, and this image, this cartoon, I think highlights this issue a little bit. A lot of the well-established devices we've been using in the lab for decades are kind of outdated now. There's been a lot of innovation in the last 10 years that the labs haven't caught up with. A lot of the frequently used devices that are out in the market that are very innovative aren't well validated. So we don't really know how accurate they are. And nothing's perfectly accurate. And so we don't know where its limitations are, or what to even make sense, how to even make sense of the data a lot of the time. A lot of newer devices use different scoring approaches and algorithms that aren't made transparent. So the device has its own determination of whether you're awake or asleep, and you can't validate it or vet it or correct for it. And a lot of newer devices are adding other signals into sleep-wake detection, like heart rate, which is probably improving things a bit. But there's still a lot we need to learn about how that works. And as information increases, questions arise as to what to do with that information. Just because you have sleep stage data from your wearable, does that mean that that information is even useful to you, or give you anything that's even actionable? Here's a recent study that was really incredible that compared a lot of devices on the market to standard in-laboratory sleep brainwave scoring. And you can see the ActiWatch on the left. This is one we use in research a lot. This is sort of the standard. And then there's some commercially available devices, Fatigue Science, Fitbit, Garmin. And what you could see is, so you have sensitivity, specificity, and accuracy. Accuracy is what percent of the minutes of the night were correctly identified as either sleep or wake. Most people spend most of the night asleep. So sensitivity, which is how many sleep periods were correctly identified, is very high. Specificity is how many of the wake periods during the night were actively found. Because if you're spending most of the night asleep, if you are better at finding sleep than wake, you're going to miss wake. So you can see lower specificity means they're missing more of the wake periods during the night. And you could see that except for the Garmin devices might have some more problems than some of the others. This is sort of the weak point for all of them. But you can see they're performing okay, especially compared to what we've already accepted as reasonable, which is the ActiWatch. Looking at sleep staging data compared to in-lab, you could see that there's some relative accuracy here. It's still just a ballpark. It's not quite enough to be totally reliable, but it's actually quite good in some of these devices, especially looking at some of the deep and REM sleep. Light sleep is very hard to discern. Now, then you have these Nearables, where you have sensors on the bed or under the bed or next to the bed or even in the bed. And when you compare some of these devices, this is from that same study, we could see that the accuracy is similar to some of the wearables, where it's actually quite high. And the sleep staging data is also actually not too terrible. It's still just a ballpark, but it's important to know that these devices, at least the ones that are better validated, actually do seem to be giving useful information about sleep versus wake. But this is nothing compared to where we're going. The future, there's sensors everywhere, and the sensor technology is getting better and better and better. And as we develop these ecosystems of sensors, we'll be able to get all kinds of really interesting information about sleep, sleep behavior, sleep environment, to be able to make better clinical and other useful recommendations. And then we're getting into the era of big data, where there's data everywhere. Where we can be merging different data sets, whether it's your health records with your wearable data and genetic data. I mean, so we got to be very careful in terms of privacy and ethical concerns, but the data are starting to become out there and starting to become leveraged to better predict outcomes. But maybe we're the problem. So mobile technology could be great, but it can lead to, especially when you use it at night, you get this tripartite outcome of light exposure, which sends a daytime signal to your brain when you're trying to wind down. Mental activation, because you have all of these signals that are giving you emotional responses. They're made to capture your attention. So, you know, you're upset at people wrong on the internet at night, or watching an exciting video or something, as opposed to something relaxing. Then you have the time displacement. This is where you lose sense of the passage of time. Where you're just so distracted, like a half an hour or an hour goes by and you barely even noticed. And so all of the sleep you're not getting, actually you didn't need all this screen engagement. So you get these things that combine together, which lead to things like delayed bedtime and sleep loss, sleep fragmentation, circadian disruption, conditioned arousal, and disordered sleep. So we got to be careful about mobile device use at night. A little bit about big data, mobile devices across the pandemic. So here's some data we just published using some Fitbit data. So this is the one thing that relates to some of the consulting that I've done with Fitbit. This is actual Fitbit data that I worked with them on to get published, where you could see during the early months of the pandemic, you had January, February, pre-pandemic, then you had March and April. Look at what happened to how much people were sleeping. People were on average sleeping slightly more, especially on weekdays. You can see the jump up of sleep time on weekends. The difference between weekdays and weekends was actually getting narrower and narrower. And you see this slightly increased sleep time all the way up to age 65. 65 and over, you don't really see it as much. But you can see maybe this is the not needing to commute in the morning when people were on lockdown. And people are staying up later across age groups. Not as much on the weekends as they are on weekdays, but you could see this drift towards staying up later and later on the weekends during especially March and April in the peak of sort of lockdown pandemic time. So here's a way we can use some big data around sleep to help see what's happening at the population level. But I'm going to end with this picture. This is an infographic that was made by a couple of the grad students in my lab, really looking at the pandemic and looking at technology and society and how it's impacting sleep. On the top, you have someone sleeping relatively well, going to bed at a normal time. And you can see their activity patterns are all lined up across the day, and their melatonin rhythm is in its normal spot in the night, and they're happy. But then during the pandemic, you have more worries and concerns, more nighttime device use, light exposure, mental activation at night, which is then leading to disrupted circadian rhythms and disrupted sleep. So for some people, they're sleeping more and better. For some people, it's leading to more disruption. And so right now, we're just looking at data to see how we can better understand this. And that's where we're going in the future. So thank you very much. Quick plug to our lab. Here's all our students, and here's the staff that work in our lab, our funding support, and here's our lab website. Feel free to check us out, see what we're doing. We do seminars also, freely available. And so thank you very much. Here's my contact information. Feel free to contact me by email. Here's my Twitter account. Follow me, send me a message. I'm happy to interact.
Great. Thank you, Michael. How are we doing on time? Do you have time for answering some questions?
Sure.
Great. Let's see. So, I mean, yeah, again, thank you. Very eye-opening statistics and very wonderfully motivating stuff. So I thought I would start with a question about, since we're talking about technology and all the myriad ways that it does influence our sleep, could you say a little bit more about, particularly the blue light effect? So, I mean, it feels especially pertinent now when many of us are on screens right now, and it might be nighttime for us. But what do we do about that? How do we safeguard some of our nighttime time habits when it comes to light pollution and these sort of things?
Yeah. So the reason why blue light is important is that we have sensors in our retina that sense different frequencies of light. And light in the blue-green spectrum sends a signal to your brain to say that it's daytime. Because evolution figured out that blue-green light, whether it's the sea or the sky or the natural world, those are the frequencies of colors you see during the day in the natural world. Because remember, this is old code in our evolution. Where red, orange, yellow, those are not really colors that are predominantly you see during the day. That's more fire, dawn, dusk. So when you get a bright blue or green signal, which includes white, so artificial white light has all the different frequencies in it, including blue and green. So when you get blue and green light or white at night, it sends a daytime signal. When the body's expecting a nighttime signal, it can get confused and can make it harder to sort of get into a nighttime mode and able to fall asleep. And so a really simple way to fix this is block the blue or green light. If you're on a screen, you can use a screen filter to block it, or glasses. You can get blue blocker glasses. And as long as the lenses are orange enough that when you put them on, if you hold a piece of something blue in front of you and you can't see the blue, it means it's blocking it. And that means it's good. If what you're seeing, if the lenses are kind of lighter and a little more transparent and you see blue, it means that they're not blocking the blue enough to impact. But yeah, so blue blocking glasses, great, ineffective, inexpensive, very effective sleep technology.
Great, good to know. Number of questions here. So I'll do my best, everyone, to combine things a little bit. So we'll see, we'll try to get through as many of these as we can. From Paul Klein, we have a question about chronotype. So in your research, does the data bear out the notion of early morning, like morning larks and night owls, or is this a misconception or a myth? Or
no, this has been around since the 70s. Yeah, like it's so think about it this way. Everyone has a biological night where their body has its nighttime when it wants to sleep. But just like everything else in biology and nature, there's variability. Some people are taller than others. Some people require more caloric intake than others. Some people, their biological night is a little earlier. Some it's a little bit later. Some it's a little longer. Some it's a little shorter. Most people are probably around the average, and there are people closer to the extreme. So there are some people who are sort of extreme night owls or extreme morning people. They exist. And biologically, it doesn't seem to be particularly harmful. Night owls do seem to be at higher risk of some mental health issues and some metabolic issues, but that it's not clear whether that's from the circadian genetics itself, or because they are involved in these things, or it's just your peak time is when everyone else is asleep, so you're more isolated and everything's closed. So it's complicated, but yeah, chronotype is a legit thing. It's an issue where maybe we should be more flexible to people's chronotypes and not guilt people for being nighttime people if that's when they're productive.
That's a big topic too in education, certainly, in terms of teenagers, and for a number of reasons they need more sleep for their developing brains. Like, should school hours be bumped back a little bit so they're not waking up at 7 a.m., 8 a.m.?
The data is clear that high schools should not be starting before 8:30. I had calculus at 7:20 in the morning when I was in high school. I blame my calculus grade on that, which is why I went into psychology, I guess. Yeah, I mean, the data is crystal clear. Telling an 18-year-old to wake up at 5 o'clock in the morning to get ready for the bus, to get to school on time, which is when a lot of this happens. 5:30, 6 a.m. is when people are getting up. That's like telling a 40-year-old to get up at 2 or 3 a.m. to get to work. How would you feel if you had to wake up at 3 in the morning or 4 in the morning every day just to go to work? How long would you last before you started getting cranky, irritable, unable to focus? Your appetite would be all off. Your productivity wouldn't be optimal. I mean, seriously. It's the lowest hanging fruit in terms of policy change. It's a no-brainer.
I mean,
No
me
pun intended.
personally, I would quit in the first day or two, probably.
Yeah, and this is what we're putting our kids through.
How about a question on the other end of it, since we're talking about waking up hours? What about, Rajveer has a question about, do you have any practical tips on how to sleep better and faster? I know a lot of people have talked
Yeah.
about like kind of the breathing methods and these sort of things, but what is your advice?
So here's my advice. If you're in a car and you want to stop at an intersection at a stop sign, you don't start touching the brakes right when you're in front of the stop sign. You start slowing down a little before. If you don't start touching the brakes till you're an inch in front of the stop sign, you'll end up in the middle of the intersection where you don't want to be moving. If you want to stop at the stop sign, you start slowing down early. The faster you're going, the sooner you need to start slowing down. And this is the same thing at night. If you don't stop your mind, we live very busy, distracted, active lives in our society, especially focusing on productivity. And if we don't give ourselves that time, it's just time. If we don't give ourselves that time, where the first chance we get to start winding down, we're already in bed. People say, I get into bed and my mind just won't slow down. It's like, well, yeah, I get into the intersection and my car just won't stop. Well, what did you do to set yourself up for that? So I would say the number one thing is people need to understand that detaching is a process and they can't always rush it. You can slam on your brakes, but that's not comfortable either. And that's not always even going to work. And eventually it'll wear out your car. So yeah, I think that's my number one thing is to actually schedule in that wind down time, budget for it. What I would do actually, this is sort of a trick in the sleep world is a lot of us have alarms we set when to wind down, but we don't set an alarm for when to wake up because our body will wake up naturally if we're prepped for it. So the alarm on my phone is more likely to tell me when to wind down to go to bed than when to get up in the morning, unless I have to get up extra early for some reason. So yeah, maybe you need a wind down alarm. Maybe you need somebody to say, now is the time to start powering down those large electronic devices. If you're here's my tip for media. The standard approach is to say, put down screens 30 to 60 minutes before bedtime. And if you can do that, great. If you can't, if you need to be on screens, at least do something that's not too engaging. And a good rule of thumb to figure out whether it's too engaging or not is if an alarm went off and said, put it down now, if you would fight it and be like, no, I don't want to, it means what you're doing was too engaging. If you're watching a show mindlessly in the background, don't really care that much, fine, maybe. That's a good, your mind has enough space to wander and you're fine turning it off. But if you're like, no, I want to watch the end, that was too engaging. Like you're not able to detach.
I think that's good advice. I really like the breaking the car slowly analogy. I feel like that's a good way to kind of like, realize we should slow down probably sooner than we think we do when it comes to bedtime.
And it's not the car's fault. There's nothing wrong with the car. It's the driver. The one other thing I want to say is the best bang for your buck sleep advice for anyone having trouble with sleep or who wants to prevent themselves from having trouble with sleep is something called stimulus control, which in a nutshell is if you're in bed, use the bed for sleep only. Sex is good too. That's fine. But try and limit other activities in bed. What you want to have happen is that when you get into bed, it's the place where you sleep. Just like if you sit down at the dinner table and all you do is eat dinner there, just sitting down makes you hungry because the place has the power to put you in that mental, physical state. If you go work out at the gym, even if you're tired and cranky, you get in the door, you can make it through your routine to the end because that's the only thing you do there. You get in the zone. If you sit in a dentist chair, you start getting stressed out before they even walk in the room because your body knows what's going to happen. It's going to anticipate that place. You don't want the bed to be the dentist chair. You want the bed to be the dinner table where you're hungry for sleep when you get in. Even if your mind was a little active, the bed has the power to put you to sleep. What you do is bed equals sleep, bed equals sleep, bed equals sleep. If you're in bed and you're not asleep, you get up until you can try again. Don't spend more than 20, 30 minutes in bed awake, unable to sleep. That I think is, sorry for taking a lot of time saying that, but I think that's critically important.
Yeah, I think that's really useful. We have a number of medical doctors also attending this
Sure.
chat. So let's see if we can get into some of the more medical issues. So Dr. Chris Adcock has a question for you about, is perception of well-restedness a function of unconscious adaptation, and does it correlate with heart rate variability?
Great question. I don't know the answer to the second question. That's actually some of the data we're looking at, trying to, especially using the wearable heart rate variability data in real world settings to try and correlate with some of this stuff. So I don't know the answer to that yet. The second part. The first part is particularly interesting, is what is this perception of well-restedness? It seems to, in the absence of actually being well-rested, I think it's sort of shifting of expectations. Part of it might be that you sort of have a new normal and you start making excuses for things, or you sort of forget how it used to be. But also it might actually be a problem with perception itself. It's just sort of like the drunker you are, the less able to tell how drunk you are. Where the more sleep deprived you are, you might actually lose the ability to perceive the impairment itself, I would think. So I think there's a lot to that. This idea of perceived restedness while sleep deprived, I think, is a fascinating idea that should be explored more.
Interesting. We have several questions, which I'm going to attempt to combine here about
Okay.
in terms of hours of sleep. So like, what part of the questions that I'm seeing here are about duration. Is it okay to break it up a little bit? Like, say you have to feed a baby in the middle of the night and do 2 4-hour sleep sessions. And also, how much does it matter, positive or negative, in terms of, like, does it matter if we sleep at 8 to 4 or 1 to 9 or something like this?
Yeah. So the good thing about sleep is you don't have to have perfect sleep to have perfectly fine sleep. Um, what I would what I would say is good sleep is where out of 24 hours, you're getting probably 7 to 8 hours of sleep. Um, the vast majority of it is during your biological night, whenever that happens to be. It's probably going to be at night. A nap during the day is probably fine, but you get diminishing returns if it's longer. Um, doesn't have to be all in one chunk. The typical adult actually wakes up 10 to 20 times a night. They just don't remember. That the awakenings happen is actually not a problem. It's that the awakenings blossom into awakenings long enough to remember that's the issue. A typical person will remember 1 to 3 awakenings a night. As you get older, that number might go up, um, with no real obvious problem associated with that. It's when there's a discrepancy between when you're awake and when you're trying to sleep is more the problem. So some people, they'll wake up during the night, they'll be up for a little while. They just don't have enough gas to make it all the way across the night. So they have a pit stop during the night where they get up, they might get a drink of water, they might even, read a book for a while, listen to a book on tape. It's nice and quiet, nobody's bothering them, and they go back to sleep. And that's their routine. They budget for it, so it's not stressful. Waking up in the middle of the night itself isn't the problem. It's when it's happening a lot or when it's disruptive that's the problem. So, but a couple awakenings is no big deal.
Good to know. We have a related question, since you're talking about audiobooks and book reading in these. Ben has a question about, could you talk about the effects of listening to podcasts or audiobooks before falling asleep?
Yeah, I mean, just so the fact that it's not visual is probably better than watching something that's visual. Probably the best activity is probably reading, because it's, even though it is visual, it's totally at your own pace. And like, if your eyes are drifting off, you can't read anymore. And it's at your own speed, where other media is going at its speed. But if I had the choice between like a TV or something audio, I'd go with audio, because the sound will, if you start nodding off, the sound will start dropping out. So if it's something that's relaxing, it might help. There's a lot of podcasts and audio programs out there that make claims about improving sleep or helping people sleep. To my knowledge, there's no actual data to back that up, but my guess is that it might help people wind down and relax and give their mind something to focus on a little bit. So probably can't hurt, but I don't know how strong of a claim they can actually make. But if it helps you, I certainly wouldn't tell you not to do it.
We have a number of questions also on the wearable stuff that seem to spark quite a bit of interest. I'm going to combine a couple here, but we
Okay.
also have one from, let's see, I'll start with Aaron Flynn Evans, who was actually our speaker from
Hey,
last
Aaron.
night. Hi, Aaron. Her question is, many sleep wearables provide feedback to users. Could you speculate on what impact that might have on the user? Do you think the potential for a device to provide inaccurate information could cause stress or mask potential clinical sleep disorders?
Yeah, I mean, obviously, I think the issue about this that I think is really, really important is that wearables are measurement devices. And a bathroom scale is not a weight loss program. It just gives you information. You could have the most accurate bathroom scale in the world that also gives you your weight and also tells you your electrical resistance and all these other things that these fancy devices are doing these days. And they could be accurate. But is that information useful? And sometimes it is, and sometimes it isn't. I think, the feedback itself and how the feedback is presented, I think is really important. I think that that these wearables, people using them and people designing them, should be taking into account how the information is going to be used. How do you present, even if you're just doing feedback? How do you present information that's accurate and has integrity, but also qualifies it appropriately? And then if you have other interventions built in and recommendations, how do you know those are going to be helpful and work? I mean, if you're constantly telling people that their sleep is bad, but yet they feel fine, is that going to make their life overall worse? Or are you uncovering a problem they didn't know they had? I mean, these are open questions. I think the proliferation of wearables is a new thing, and I think we're going to learn a lot more about this. I think for some people it stresses them out. Honestly, I think that that's happening a little less as people are getting used to it. If anything, people are realizing that some of this information might not even be super useful. Like sleep stages data on wearables, for a lot of people, might not be very actionable. So what? I'm getting X number of minutes of deep sleep. Is that even accurate within the margin of error? And what would one do about that? There's not really anything you could do to change that. So I'm actually looking forward to the future where we're tapping into signals to get novel insights that tell us things that we didn't already know, that can predict future behavior in more useful ways. But yeah, I think measurement alone isn't enough. We need to give feedback, but the feedback needs to be true, needs to be accurate, needs to be digestible, and at the same time needs to have integrity. And that's always a tough balance.
Those are very good points, and I feel like we have a related one, and this is a question I've wondered about too, and I can relate to. I have my Fitbit that I still wear. I don't wear it to sleep actually, because it had the novelty in terms of. You're totally right. The data didn't really mean anything to me after a certain point. I was like, I'd rather
Yeah.
just not wear it at night. It didn't do anything, and I didn't know what to do with it. But Mark Harper's question is: does the LED light from the HR sensor in a smartwatch affect sleep quality? Good question.
Not if it's not shining in your eyes. If it's shining on your skin, it's not going to do anything. But what happens sometimes is some of the devices are a little sensitive, or when it's trying to sense when you're going to turn on the screen to look at it. And so when you roll over in the middle of the night and then the screen comes on,
Right.
and you have your hand up to your face and it shines right in your eyes like that. So the people who make those devices should be aware what time it is before they start shining bright lights on people. But the LEDs on the back that are on the sensors, they should be against the skin. So if you're seeing that light, it means it's facing in the wrong direction, or it's too loose.
Yeah, possibly too loose. Speaking of wearables, we have a couple of questions about multiple people have asked, are you familiar with Whoop or
Yep.
Ring or a
Yep.
Ring, Apple Watch, and just in
Yep.
general, could you speak to their effectiveness, like your opinion on those?
Well, so in terms of accuracy, so one thing with the Apple Watch is it looks like the accelerometer in it is, and the sensors in it are quite good, but it looks like it could be very accurate, but there's lots of different programs. There's no one sleep scoring program. So each one probably has its own algorithms and its own things. So who knows whichever one you're using. There's some validated algorithms, but they're mostly used in research. Aura has some pretty good data for it. They're one of the few devices that actually did put in the effort to validate their devices. Whoop is a more recent entry. They're more in the sports performance space. Their sleep tracking seems to be accurate enough, at least on par with other stuff that's out there. They have other metrics in there like recovery and things that I can't really speak to that because that's not where my expertise is in terms of how to use heart rate to predict recovery. I think that the jury's still out on how what those data actually mean, but the sleep tracking is probably fine. And there was even a study that using Whoop that showed that on average, the feedback may have helped a little bit in terms of improving people's perceptions of their sleep, whatever that's worth.
I'm mindful of time in that I don't want to blow through lunchtime, your time, but maybe we'll do just a couple more questions if you're all right.
Sure.
There's a good one here from Isabel. Of all the issues and charts that you've presented on the risks of sleep deprivation, which ones would you wave strongly in front of public health decision makers and employers to make them wake up? I like that. Wake them up to the importance of sleep.
Yeah, that's why we did that behavior study to see, like, what do individuals care about? And so, like, okay, if I were going to talk to people on the street, I'd talk about mental health and mental performance and maybe weight. If I was talking about employers, I would talk about, depending on, in the US, I'd be talking about healthcare costs, where we have data showing that the worst sleepers in an organization are costing, $3,000 to $8,000 more per person per year on healthcare costs. And as their sleep gets worse, the costs go up. So in a large employer, there's millions of dollars there. In terms of productivity, the estimate is that someone with insomnia or insufficient sleep, either one, you're losing about $3,000 in productivity per person per year. And so again, it all adds up. And then that's just sort of the average. You also have increased absenteeism. You also have increased disability because of injuries and things. My perspective is find the outcome that people care about. The good thing about sleep is it's connected to all of them. Sleep is just so fundamental to our functioning. Whatever outcome you care about, there's a sleep story there. Lawmakers, if they care about health equity, talk about disparities. If they care about education, talk about school start times. If they care about health funding policy, talk about the cost savings of addressing sleep problems rather than letting them go while treating the other medical conditions that don't get better because sleep is in the way. That's the good thing. Actually, instead, what would I tell them? The first thing I'd do is I'd ask, and I'd say, what is it that you actually care about? And then I'll tell you how sleep is related, because it probably is, to be honest.
Speaking of the kind of policymaker and some of these things, I figured let's end on one of the big questions. I'm going to combine Julian's questions here. So we're kind of the engaged audience, right? Like we're interested in hearing all of these things and wanting to take action on that. So one part of the question is how do we? And I guess this goes back to your opening, right? In terms of lack of sleep and being productive is somehow like a weird badge of honor sort of thing.
Yeah.
How do we change some of that? And also on the individual level, we've talked about some of the behavioral change. What policies should we do at the governmental and societal level to take care of the population's sleep in general?
Yeah, so when I work with athletes, a lot of whom don't get enough sleep because they're often up very early and then they're working late, especially the student athletes turning in homework at midnight, but then having to get up at 5 to go train. I say, look, what if I had a routine for you that could boost your athletic performance by, depending on these objective study, between 10 and 30%? Would you do it? And what if that exercise routine, you could do it in your room every night. It would take 30 to 60 minutes. The more you do, the better. And the main side effects from it is your grades will probably go up, your mental health will probably improve, your relationships will probably get better, and you'll be better. Your appetite will be more under control. Would it be worth it to do? Would that be worth trying if I gave you that routine, that exercise routine to do in your bed every day? And they'd say yes. And I'd say, all right, that's what the extra sleep time is going to do for you. And rather than see, and the whole point of this is, rather than see sleep as a cost, we live paycheck to paycheck with our sleep, where at the end of the day, how much change do I have left in my pocket? How many minutes do I have left in the day before I have to get up the next day? And that's how much I allow myself to sleep. But instead, that's no way to live. We need to be investing in ourselves. We need to be saving. If you spend all your paycheck every week, it's really hard to progress. Some people have no other choice, and that's just the way it is. But some people do have more control than they realize. Even putting a little bit away can help. And just like with sleep, seeing sleep as an investment, instead of saying, how much time do I have left in the day to sleep? Think, how much sleep do I need to get tonight to be optimally functional tomorrow, so that I don't need to stay up so late because I'll be more productive and effective? When do I need to start putting things down so that I can be as effective and productive tomorrow as I need to be? And that's the decision you should be making. And even if it means stopping a little early, a lot of people say it's that they don't have time. What if the reason you don't have time is because you're inefficient because you're not well rested? What if I could give you back that time? And that's actually what we're finding, is that by increasing sleep, you're increasing efficiency and productivity. And what used to take an hour to do is now done in 40 minutes, so that you can actually have more time and you're actually better in balance. So maybe it's not about convincing you that sleep is really important and to get more. Maybe it's just about seeing sleep as the investment in the next day, and thinking about it that way, seeing sleep as an investment instead of a cost.
I think that's great. I think on that note, since we're winding down, I'll take
Yeah,
one last question here from
sure.
Jamie in terms of how about all of us on the on Greenwich Mean Time now, since it's the evening for us. How do we wind down? What should we do? Like now, I'm speaking in general. What should we all do for our evenings after we've had kind of like a mentally engaging sort of thing? Any tips on what should we do collectively to kind of like build in more of the wind down time before sleep?
I think, humans used to be way better at this. We used to sit around and talk or read, before we had TV and movies and everything on demand all the time at maximum intensity. I think what I don't think what it is that you're doing actually matters as much as the quality of it is. You're not amping yourself up. You're not getting yourself excited. You're working through stuff. You're processing things. Some great things to do besides reading and talking to people, um, things like making lists. Like make lists of what you need to, like when you get into bed, all those things you're going to be thinking of for the next day. Do it now. Like, all right, if I were going to get into bed, what would I be worrying about? And you start making your notes for tomorrow. So by the time you get into bed, you're like, I thought of this already. I already did this. It's done. I can't be helpful in bed. Before going to bed, you might be able to be helpful. Um, Another thing, listening to things is good. Reading is great. Dimming lights. So this is another thing. Dim all the lights in your house about an hour or so before you want to go to bed. It's a subtle cue to your body to start winding down. Slow down. Be a little quieter. It's find those quieter activities, and what'll happen is your body will start getting the signal. Remember, your body's a pattern recognition machine. Feed it a pattern, and it will learn it. So the exact thing you do, I don't care, but it's the character of it. Make it a winding down. Make it a slowing down. Make it a not so distracted. Again, if it's something that you can't pull yourself away from, it's too engrossing. That's not the time for it. Maybe that's the only time in your day for it. But does your life really need it? If it's a show, if it's another episode of a show, it'll be there tomorrow. This is the great thing about like having streaming and on-demand stuff, is the show doesn't care whether or not you watch it. It's not offended if you skip it and wait till tomorrow. It'll still be there.
I think that's great advice. So I think, well, thank you, Michael, for a wonderfully motivating and very thought-provoking talk.
Thanks.
I'm sorry I didn't get to everyone's questions. You can reach Michael on his
Yeah.
website, michaelgrandner.com, and also his Twitter handle, same name. So feel free to ask questions that way. But this was great. What a thrill. Thank you. And you're welcome to come to Cambridge anytime. If anyone knows how to deal with the jet lag and the time zones, I assume it would be you.
But once the world opens back up.
Yeah, it'll at some point, maybe not right away, but yeah, let us know when you're in this part of the world.
Take care. Have a great night, everybody out there, and the rest of your day, everyone who's on this side.
Thank you everyone for coming, and good night or good afternoon.